Hello math students, Dr. John here. We are trying to take this polynomial, this rational expression of polynomials divided by another rational expression of polynomials, and put it into simplest form. Of course, you'll realize you're going to have to flip and multiply when you do that, but since we'll want to express this in simplest form, the best thing that we can try to do is see if we can factor each of these terms. I'm going to start off with one term at a time and see if I can factor it, and then write what I found over here so that we can start canceling things off, hopefully. Let's take a look at this first term here. X squared minus 5x minus 24. So when we're trying to find the factoring for this, we're basically trying to find rather simple, straightforward factoring so that we can cancel things easily. We're not trying to find really complex factors that involve fractions or roots or stuff like that. So we can do this with this brute force method. This first one has to be an x and an x, and it has to be a plus and a minus to make this minus. What would this be? What multiplies together to give you 24, but adds up, or minus 24, and adds up to be 5? So let's take a look. 24 could be 1 and 24. Well, that's way too big. It would have to be minus 24. 2 and 12, minus 12, that would be minus 10 if you add them. And what else is there? 3 and 8. If it's minus 8, this would be 24, and this would be minus 5. Aha, we found it. So it's 3 and minus 8. So this would be minus 8 plus 3. Let's check everything out to make sure it works. So it's this times this is minus 24. This times this is x squared. Cross terms, 3x minus, it works. So this here is now this top factor. I'm going to write this over here so we have it nice and clean over here. X, that's this term here. Let's take a look at the second term, the bottom one for that. This one right here. So it's x squared minus 11x plus 24. How can we factor that in a nice, clean way? This has to be an x, this has to be an x, and they both have to be negative for this to be positive and this to be negative. Now we have two terms that add up to 24. What can't be 1 and 24? That would give us too big a number, because since they're both negative, that would give us minus 25. And then there's 2 and 12, minus, minus. That still gives us too big of a number. So what else is there? 3 and 8. 8 times 3 is 24. 8, 9, 10, 11. If they're both negative, that would add up to minus 11. That works. So minus 3, minus 8. Excuse my messy 3. Let me try that one again. Minus 3. So this all works for this one. So we're going to write this underneath here, since that's this one. So that's x minus 3. We already see some commonality there that might be able to be canceled. How about this one over here? Tiny bit more complicated to factor. We'll try this brute force method again. That has to be 2x, that has to be x. There's no choice, and they have to be plus and plus. Those are the only choices left. Now we have to have 3 and 1 or 1 and 3. Which way around do we need to go? Let's start off with 3 and 1 here. That the cross terms are x, 6, that works. This all works for this one. Now, since this is the numerator up here and we're dividing, if we want to multiply, I'm going to take this here and move this to the denominator. Because we're flipping this fraction here over. I'm doing a whole bunch of things at once. Hopefully it's not too confusing. This is 2x plus 1, bracket, x plus 3. Now we're going to take this and put it on the top there. And we'll see if we can factor that last one there yet. X squared plus x minus 12. Hopefully this one's easy. That's an x, that's an x, that's a plus, that's a minus. Because this has to be a minus sign. This has to be x squared. So they have to multiply to give you 12, add up to give you this. That would be what? 4 and 3. 4 here and 3 here. That's 4x minus 3x gives you an x. This gives you a minus 12. That works. So writing this up here, x plus 4. One of the most important things about these kinds of problems is that you keep things really neat. I'm trying to keep things neat on the board, and yet I still make a lot of mistakes. So if you have a big complicated problem and don't keep things really tidy, it's going to be easy to lose track of what you're doing. We've done this. We've factored everything and flipped this fraction. Let's see what we can cancel now and make that an easier fraction. So on the top and the bottom here, we have this and this. And we have an x minus 3 here. I'll do an x with that. Down here we have an x plus 3. I'll do different lines. If you use different ways of canceling it, you can see what you're doing later on as well. This one has nothing on the top. This one has nothing on the bottom. So we're left with x plus 4 all over 2x plus 1. Anything else? No. That seems to be about it. So this seems to be the answer here from what I can look at. And that's all they've asked you to do at that point. Get on to the next question. However, there's one more thing that people might ask you for. They didn't in this question, but they might also say, what are the disallowed, the non-permissible values? In that case, you might say, well, here I just have to worry about when this is equal to 0. So I would take 2x plus 1, make it equal to 0, and solve for x, which is what? Minus 1/2. When x is minus 1/2, this is not permitted. But you can't use this. You have to go back to this form right here, which would be you have to look at all these things in the denominator, the new denominator. You also have to look at this denominator here, because that's the denominator of this fraction. This is the denominator of this fraction. So you have to look at both of them as well to make sure that there's nothing not permissible. So that means here too. So anything here that might equal 0, or any of these terms that might equal 0, would not be permissible values for this fraction or this operation that you're doing, the operation of division in this case. So that would be something that you might have to do for another problem. Not needed for this one, but hope that helped, and we will see you in the next problem. Bye-bye.